Okay, yes, we are live. Okay, sorry guys, actually this session is at 11 p.m. but for 2 days, that is for today and tomorrow, this session will be at 7 p.m. So kindly do adjust to those timings. Okay, yes, so moving forward with that, you guys know about the Unacademy combat. So the next combat is going to be live on the 4th of July. It starts at 11 a.m. So please do use my code SAYT. Please do use my code SAYT and join into this free scholarship combat. Yes, these are the plus subscription. These are the offers on the plus subscriptions you guys will be getting for getting ranks 1 to 100. Okay, yes, so this is about the plus subscription. You guys can see, you guys get access to all these eminent features. You can go for the iconic one also, where along with this, right, you guys will be getting access to 4 of these features. So you guys can use whatever subscription you want to buy. Okay, just use my code SAYT. Using my code SAYT, you guys will be getting 10% off. Using my code SAYT, you guys will be getting 10% off on all subscriptions of Unacademy, including the GATE ESE Plus and Iconic. Okay, so in yesterday's class we learned clearly about the time and work, the concept part 2. So today we are starting with time, speed and distance, and tomorrow we will be starting with trains, right? Today we'll starting with time, speed and distance, concept number 1. Time, speed and distance, concept number 1. So yes, first thing is, right, whenever time, speed and distance problems are given, people get confused in converting kilometer per hour to meter per second. Yes or no? So yes, so I'll give you guys a small introduction on it. Kilometer per hour to meter per second, we always use the chronology 5 bar 18. You're converting kilometer to meter. You're converting kilometer to meter. That means the numerator is going to be less, right? When you're getting meter per second and you have to convert it to kilometer per hour, it will be 18 bar 5. Because the meter to kilometer you are converting from a small quantity to a big quantity, so the numerator will be high, right? How? I'll tell you guys. Because you guys know 1 kilometer is 3600, sorry there, right? 1 kilometer is 1000. Yes or no? 1 kilometer is 1000 meters, whereas 1 hour is 60 minutes into 60 seconds. Okay, which is nothing but 3600. So if you take the division of both these, this is nothing but 1000 divided by 3600, right? Okay, so this goes to be 10 bar 36. Yes or no? Kilometer per hour to meter per second. Kilometer per hour to meter per second. So this will be 5 bar 18. When it is meter per second to kilometer per hour, it will be the reciprocal of this. This will be 18 bar 5, right? This will be 18 bar 5. Okay, 3600 by 1000 we will do. Right? A small concept which needed a relook on. Now let us go to the next concept. Okay, yes. Moving on to the next concept, you guys know, right, about the distance being constant, about the distance being same. Okay, so if I mark a territory A to B, if I mark a territory A to B, okay, and if I tell you the distance is constant here, okay, the distance is constant here, okay, so the speed from this part will be x, the speed from this part will be y. Yes or no? The speed from this part will be x, speed from this part will be y. Okay, yes, both of them are going in the same direction, both of them are going in the same direction, right? X and y. So I will just erase of y there, I'll put y here. Okay, yes, this is y. Okay, so the time took by this person, will be t1, the time took by this person will be t2. Okay, time took by this person will be t2. As we know distance is constant, I can write distance is what, remember? Distance is speed bar time. Yes or no? Distance is what? Speed bar time. And you guys know here that if I add t1 plus t2, if I add t1 plus t2, it will give me what? If I add t1 plus t2, it will give me what? It will give me the total time. It will give me the total time, that is t, right? Give me the total time, that is t. So you know, if I want time here, it should be distance bar speed, right? If I want time here, it should be distance bar speed. So distance is constant, so t1 is going to be d bar, what is the t1 speed? X. t2 is going to be, what is this? D is constant, but what is the speed here? What is the speed of this? Y. Yes or no? This is y. Okay, this is y. Now, yes, so this is equal to t. Yes or no? This is equal to t. That is our total time. So you can see here d is constant, right? D is constant. So x plus y will be what, Baba? So here d is constant or d is this. So when I solve this, this will be equal to dy plus dx divided by x plus y is equal to t. So I know d I can write it as common. So if I take d as common, this will be x plus y is equal to t into x plus y. Yes or no? Right, x plus y, wait, dy plus dx. Wait a minute, dy plus dx. Yes, dy plus dx, xy. Sorry, it is not x plus y. LCM, right? It will be xy. Okay, LCM, right? It will be xy. Okay, yes, sorry there, right? So here xy, t into xy ho jayega. So if I solve this, if I want to solve this for d, if I want to solve for my d, if I want to know the value of my d, so this is going to be what, Rebaba? This is nothing but xy divided by x plus y into t, where t is nothing but your total time, where t is nothing but your total time. Okay, t is nothing but your total time. Here, when I don't know the value, right? So this I can tell when x is greater than y, right? This I can tell when x is greater than y. When speed 1 is greater than speed 2, when the value of speed 1 is greater than speed 2, then this formula can be used. Okay, then this formula can be used. Okay, what if y is greater than x? That is our next concept. Okay, that I am solving in this page. Okay, what is y is greater than x? Right? What if y is greater than x? So the next concept here, yes, we are having the same distance. We are having the same distance AB. Right? This is my speed x. This is my speed y. Okay, my distance is constant as you all know. So my time here will be t1 and my time here will be t2. Right? My time here will be t1 and my time here will be t2. But here I give you guys a different condition that y is greater than x, right? I give you guys a different condition that y is greater than x. If y is greater than x, right? If both of them are going in the same direction or something, if both of them are going in the same direction and one speed is greater than the other, we will take it as what? T1 is greater than T2, right? It is basically T1 plus T2. But here if y is greater than x, our T1 will get changed, right? So our delta T will come into difference here, right? Yes, why is this? Because there will be difference of two speeds here. Understood, guys? So this is, so here it can be x is greater than y or y is greater than x, x is greater than y or y is greater than x. But here when the total time is given, right, when the total time is given, you guys will be using this formula. When the total time of a person, what is total time? Basically I will write it as tt, right? What is total time? Basically total time is the time took by both the ages, right, or time took by both the speeds. This takes 5 hours, this takes 8 hours, so the total time will be 13 hours when total time is given. When they give you something, when they give you something called as the difference in time, right? Yes, the difference in time of reaching both the places was 3 hours. The difference in time of reaching the places was 4 hours. What is difference in time? Difference in time is always going to be t2 minus t1, right? Yes or no? Difference in time is always going to be t2 minus t1 here. Yes or no, people, right? Yes, it can be t2 minus t1 when it is y is greater than x. Okay, it can be t2 minus t1 when y is greater than x. It can be t2 plus t1 when y is less than x. Right? It can be t2 plus t1. It depends on the speeds. Okay, so what is difference in time? What is difference in time? We tell it normally. Difference in time normally is t1 minus t2, right? Difference with both the times. Yes or no? So here we know, we already know the formula. T1 minus T2 is equal to delta T. What is T1? T1 is d bar x because our distance is constant, minus T2 d bar y is equal to delta T. So this is again going to be dx minus dy divided by xy is equal to delta T. So here d will be common, right? D will be common. So if I can write it down because we solved this formula just 2 seconds before, right? So d is going to be what? D is going to be xy divided by x minus y into delta T. xy divided by x minus y into delta t. B is going to be xy divided by x minus y into delta t. What if it is, see, so this formula is when x is greater than y. Okay. When y is greater than x, it will be y minus x. Okay. When y is greater than x, I'll write it just here only. When y is greater than x, this will be y minus x. Okay, xy is going to be same, it will be y minus x, because speeds cannot be negative, right? So I cannot tell if y is greater than x, so I cannot tell x minus y will be there. We should take the mod of both the things, right? We should take the mod of both the things. Greater minus lesser. Speed is never a what? Speed is never a negative quantity. Speed can never be a negative quantity. Okay, these are the two main concepts. Now the third concept, right? Yes, most of the people get confused here. If I tell someone is 2 hours late, what does it mean by someone is 2 hours late? What does it mean by someone is 2 hours late? Someone is 2 hours late, matlab, right? There will be original time and he will come 2 hours after it. Yes or no? There will be original time and he will come 2 hours after it. Let us assume this as our T1. Okay, early concept. I will tell someone is 3 hours early. 3 hours early to what? 3 hours early to some original time. Yes or no? 3 hours early to what, people? 3 hours early to some original time. So original time, he has reached 3 hours early. That is, he has come 3 hours early. Minus 3. If original time was 5 hours, he has come 3 hours early. So it comes at 2 hours. Right? This is our T2. Okay. What is delta T basically, people? What is delta T? We already know delta T here, right? So delta T is going to be T1 minus T2, right? So we are comparing to the original time, what would have been the time they came, right? The difference of time of both the people here, right? T1 is going to be T plus 2 minus T minus 3. So this goes to be T plus 2 minus T plus 3, right? What will be the difference of time? The difference of time will be 5 hours. Yes or no? Minus into minus will get plus, right? Minus into minus will get plus. The same concept, thoda or extend. Okay, so there will be another question where both are late. So this person is 2 hours late. This person is 3 hours late. Okay, so this is going to be T plus 2. This is going to be T plus 3. So what will be my delta T, people? The difference in time. So it is T1 minus T2. So this goes to be T plus 2 minus T plus 3. So minus and minus will get cancelled anyways, T and T. So plus 2 minus 3 will be there, right? Plus 2 minus will be there. So minus 1 aa gaya. Time cannot be negative, right? Time cannot be negative. Here what was it, people? Plus 5 hours. That means from the original time, they were late by 5 hours, right? Plus means what? Plus means late. Minus aa gaya, time cannot be negative, no sir, right? Everyone will have this doubt. It is not that time is negative here. Minus 1 means this person has come early. Their total speeds or the accumulation of their total speeds or the difference between their total time was 1 minute earlier to the original time, right? Was 1 minute earlier to the original time. So you guys can take the value of T here, right? You guys can check for yourself. We don't have much time here, right, for checking this, right? You guys can check for yourself. You can take the value of T as 5 or 4 and you can check it, right? You're getting the value of delta T as it is, right? You're getting the value of delta T as it is. Okay, so this is the normal concepts, right? These are the normal concepts. Let us go to the next concept, right? Let us go to the next concept. So if you guys know the speed distance formula, speed distance time formula, if you guys know the speed distance time formula, you guys will know this clearly, right? So distance is nothing but speed into time. Yes or no? Distance is nothing but speed into time. So I can write this as what? I can also write this as, if I need speed, then it is nothing but distance bar time. If I need time, then it is nothing but distance bar speed. So here also, can we use our RC, which is our ratio concept? Yes. So what is it? Speed is inversely proportional to time, and if time is constant, Please do listen to this. Time is constant, okay? If time is constant, this is only for one, then I can also tell speed is directly proportional to distance, okay? So this one applies everywhere. The red one, what I have written, the formula here in the red color, this applies everywhere. This applies only when time is constant. So if I give you guys x is going with the time t1, y is going with the time t2, okay? So if we take the ratios of their speed here, the ratios of their speed will be x is to y, but their time has to be inversely proportional here, right? Their time has to inversely proportional, right? So x ka speed will be equal to y ka time, and y ka time will be equal to x ka speed. So this will be t2 is to t1, right? This will be t2 is to t1, right? So this is the normal one, right? So now here, if someone gives you the speed value is x is to y, and they do not give you the value of time, you don't have to worry much about it. You can take the reciprocal here itself, right? X is to y is nothing but y is to x, right? Yes, the reciprocal of this. But these things will be encoded with the letter r or x, as these are ratios, right? These things are encoded with the letter r or x, as these are ratios. Now here my time will be what, people? What is going to be my time? My time is nothing but, you guys know that our total time is nothing but t1 plus t2, right? So what is going to be my time here, right? My time is nothing but x plus y or y plus x. So no, x plus y is going to be my time. So no, x plus y is going to be my time. And here my full ratio is equal to this, right? X plus y. So if x plus y is equal to 5r, that 5r is nothing but t, right? That 5r is going to be nothing but t. Yes or no? That 5r is going to be nothing but t. And this x plus y is equal to t, this will be equal to one phenomenon y, or this will be equal to one phenomenon x, right? So if I had to find out the value of y here, you guys have to don't use this, right? That's okay. I'll be telling you a more easier concept when we are dealing with problems. But here, if I had to find out the value of y, right? So here I can tell the value of 1r is equal to t divided by x plus y. And what if that 1r is equal to y? So y is equal to t bar x plus y. Okay, so can I write here y is equal to t bar x plus y, which is nothing but this x is equal to y. So here my 1r is nothing but ty divided by x plus y, right? Because total time into the speed of y will give you the speed of x, right? Total y into the speed of y will give you the speed of x. Let us have a small concept here, right? You guys don't have to worry this, just listen to this. So you guys know a person is going from here, a person is going from there. So no, a person is going from here, a person is going from there. So what do we usually do? We take the value of distance, right? We write it as xy divided by x plus y into total time, right? Yes, okay, into total time. But if I tell a person is 10 minutes late, or the time took by a person is 10 minutes, the time took by another person is 15 minutes, okay? So here 10 is to 15, what is this? This is nothing but your time. So I can also write the speed here, no, right? Speed is going to be 15 is to 10. So this can be simplified further, people. Yes, this can be simplified further, no, right? So I can write it as what? 3 is to 2. And if I tell the difference between their speeds, was 40 kilometer per hour, what was the initial speed, right? Yes, so 1 hour is equal to 40 kilometer per hour. So 3r will be equal to what? 3r will be equal to 120 kilometer per hour, and 2r will be equal to 42 80 kilometer per hour, right? 2r will be equal to 80 kilometer per hour. Yes or no? If the time is given, you don't have to find out the distance, the time and all, and find out the time there, right? Directly you can use the ratio concept and find it out. Okay, ये सब करने की कोई जरूरत नहीं है, right? Okay, ये सब करने की कोई जरूरत नहीं, ये पूरा करने की 1 is equal to t by y, okay, टी वाई इंटू एक्स प्लस वाई, ये सब पूर्ण करने की जरूरत नहीं है. जस्ट यूज द रेशियो कॉन्सेप्ट हियर. Okay, just use the ratio concept here. That's it. Okay, just use the ratio concept here. So you can also find out the actual distance, this distance and all. So you guys might already know that I have already started the special classes on my Unacademy profile, right? Every day at 10 p.m. So we had done the special classes on averages, percentages and all. So I hope so you guys come to the classes there where we'll be solving questions on this. Okay. Yes. The next concept here, right? The original speed concept. Okay, the next concept here, which is the original speed concept. So the original speed concept, what can I name it as? The original speed concept, right? So if I tell, okay, just as let us take a name, Kamala. Kamala goes to a market. Kamala goes to a market with 1/5 of her original speed, right? Kamala goes to a market with 1/5 of her original speed. Yes or no? Of 1/5 of her original speed. So I know the fraction already here, right? 1/5. You guys also know from my first lecture. 1/5. You guys know it is as 20 percentage. Yes or no? So what is the speed at which Kamala is going? What is the speed at which Kamala is going? Kamala is going at a speed of 20 percentage, but her original speed is what? Her original speed is 100 percentage. Yes, you guys can take this also into reference, and you guys can tell the original speed of Kamala is nothing but, when you compare 100 is to 20 here, right? When you compare 20 is to 100, so this is nothing but 1 is to 5, right? So I can tell this is the actual speed of Kamala, this is the original speed of Kamala. Yes or no? That is what I'm getting directly from the fraction. No, that is what I'm getting directly from the fraction. So if I get a fraction 1/5 of her original speed, whatever the word runs after the fraction, if I get 1/5 of her actual speed, 1/5 of her this speed, that speed, whatever word runs after the fraction, that means that is itself the denominator. Whatever runs after the fraction, that means that is itself the denominator. So the original speed of Kamala will be 5x, okay, and this will be the speed of Kamala, right? The actual speed of Kamala. So if they give you one more bit of sentence here, that the original speed of Kamala, right? If her original speed was 50 kilometer per hour, what is her actual speed, right? Yes, original speed you guys know, 5 hour is equal to 50. So 1 hour will be equal to what, Baba? 1 hour will be equal to 10. And what is the speed of Kamala? What is the speed of Kamala? What is the speed of Kamala? The speed of Kamala is 1 itself, right? So this is your original concept speed, right? This is your original concept speed. So let me just see the time, okay? So we are already up by the time. So the next concept, right? So in tomorrow's class, I will be teaching you guys, right? I'll be teaching you guys the average speed concept, right? In tomorrow's class, we'll be moving ahead with the average speed concept, okay? In tomorrow's class we'll be moving ahead with the average speed concept, right? And the problems of trains will also be continued with this, right? Okay, so I think another 2 minutes I'll just finish off the relative speed concept. Anyways, average speed concept will take time to explain, right? I'll go with the relative speed concept. Okay, we'll just finish off the relative speed concept. Okay, yes, relative speed concept. So what is this relative speed concept, people? What is this relative speed concept, right? Yes, so relative speed concept is always dependent on relative speed concept is always dependent on directions, right? Relative speed concept is always dependent on directions. So how shall I take it, right? So let me just draw a line. So this is the distance AB, right? Okay, so there are two persons, right? A person one is going in this direction, a person two, right? A person one is going from A to B, and the person two is going from B to A. The person one is going from A to B, the person two is going from B to A, right? So what will be their directions? One is facing east, one will be facing west, right? So this is your opposite directions. Okay, whenever you guys get opposite directions, your relative speed is always going to be, whenever you get opposite directions, your relative speed is always going to be the addition of both the speeds, right? Your relative speed is always going to be the addition of both the speeds. Here you guys can assume that S1 is greater than S2, or else S2 is greater than S1, right? Yes, both the times, right? Whether S1 is greater than S2 or S2 is greater than S1, right? We will always go with the same one, that is S1 plus S2. There's someone, right? What if it is in the same speeds, right? So we'll draw the same line. So this is A to B, right? So one is going in this direction, two is also going in this direction, right? When they both are going in this direction, what will happen? There will be a race between them. As or no, what will happen? There will be a race between them. And always in circumstances, both are going to the east direction. So this will be the same direction itself. This will be the same direction itself. So your SR is going to be what? Subtraction of both the speeds. Your SR is going to be subtraction of both the speeds, S1 minus S2. And here it is always that S1 is greater than S2, right? Always it is going to be S1 is greater than S2, right? Yes. So it is not like you have to take the greater number or lesser number. It is always the greater speed minus lesser speed. Okay. It is always going to be greater speed minus lesser speed. And whenever you guys get the chronology or term relative speed, then consider it is going to be the same time. Yes or no, right? Yes, it will be same time. The distance can match this. Okay, so it is the distance. Anyways, A to B, the distance is same, right? It is going to be the same time whenever you get relative speed. That means 25 kilometer per hour, right? This one, right? Not same time, same distance. It's not going to be the same time. It is going to be the same distance. It's going to be the same distance whenever you guys are getting the relative speed, right? The relative speed concept is dependent on directions, and here the speed is always going to be same. Yes, you're going from A to B, so this is around 120 kilometers. Then from B to A also is 120 kilometers, right? A to B is 540 kilometers. Then from B to A also it is 540 kilometers. So that's it from the session now, right? So I will be taking the next concept, that is the average speed concept, and the problems on trains in tomorrow's class, right? I'll be taking the average speed concept and the problems on trains in tomorrow's class. Okay, so thank you so much for attending the lecture, guys. So the next concept will be awaiting tomorrow. Yes, right now at 8 p.m. you guys will be having a special class from my side. So those who are watching live, at 8 p.m. special class will be there. Use my code SAYT to unlock the free special class pack, right? Yes, so where I'll be dealing with quads problems, where I'll be dealing with the problems of quads. Okay, yes. So thank you so much, guys. I will be seeing you guys in the next class. Till then, have a great day. Please do take care. Stay safe.